Welcome to AI Frontiers, your deep dive into cutting-edge artificial intelligence research. In today's episode, we explore Frontiers of AI, the evolution of intelligence, as we synthesize 39 papers published on May 27, 2025. This comprehensive exploration aims to provide you with a thorough understanding of where AI research stands today and where it might be heading tomorrow. We'll examine how researchers are pushing boundaries in areas ranging from reasoning capabilities to safety protocols, unpacking complex concepts and highlighting significant breakthroughs. Whether you're a seasoned AI professional or simply curious about technological advancement, this discussion offers valuable insights into the evolving landscape of artificial intelligence. Let's begin our journey through the latest developments in AI research. Today's presentation will take us through 6 dominant research themes that are actively reshaping AI capabilities. We'll examine breakthroughs in reasoning, safety, and multi-agent systems that represent the cutting edge of artificial intelligence research. Throughout our discussion, we'll analyze the methodological innovations driving progress in the field and highlight seminal papers with transformative potential. These papers demonstrate not only how far AI has come but also point to exciting future directions. As we explore each theme, we'll also consider the remaining challenges that researchers continue to address as they push the boundaries of what artificial intelligence can accomplish. Artificial intelligence represents one of the most dynamic and rapidly evolving fields within computer science. At its core, AI research aims to create systems capable of performing tasks that typically require human intelligence. This broad discipline encompasses numerous specialized areas including machine learning, natural language processing, computer vision, knowledge representation, reasoning systems, and autonomous agents. Recent years have witnessed unprecedented advances in the capabilities of large language models and multimodal systems, which can now generate human-like text, create images from descriptions, engage in complex reasoning, and even exhibit emergent abilities not explicitly programmed into them. However, as these systems grow more powerful, researchers face growing challenges related to reasoning, safety, alignment with human values, interpretability, and responsible deployment. The interdisciplinary nature of modern AI development draws on insights from cognitive science, neuroscience, linguistics, philosophy, and mathematics. The significance of AI research extends far beyond academic interest, as it forms the foundation for technologies that are transforming industries, scientific inquiry, and everyday life across the globe. Our first research theme focuses on enhanced reasoning capabilities in AI systems. Despite their impressive performance on many tasks, current models still struggle with multi-step logical thinking and causal understanding. This represents a shift from earlier AI systems that excelled primarily at pattern recognition but faltered when faced with complex reasoning challenges. Researchers like Zhang and colleagues have addressed this by optimizing thinking dynamics to prevent wasteful overthinking in large models, making their reasoning processes more efficient and effective. Chen and team have taken a different approach with their R1 code interpreter, enhancing reasoning through code generation and execution. This method leverages the precision of programming languages to overcome the limitations of natural language reasoning. Meanwhile, Zhang and colleagues have introduced formal verification frameworks specifically for mathematical problem solving, providing mechanisms to ensure the reliability of AI-generated mathematical proofs and solutions. Collectively, these works highlight the ongoing efforts to move beyond simple pattern matching toward more sophisticated reasoning capabilities that can reliably handle complex, multi-step problems across different reasoning types, from deductive and inductive to abductive reasoning. The second prominent research theme centers on AI safety and alignment, reflecting the growing recognition that as AI systems become more powerful, ensuring their safety becomes increasingly critical. Current safety measures have proven to be brittle and easily circumvented through carefully crafted inputs. Wang and colleagues address this concern with their SAGE-Eval benchmark, which tests whether large language models can properly apply established safety facts to novel scenarios. This work tackles the problem of models that might memorize specific safety guidelines but fail to generalize these principles to unfamiliar situations. Liu and team propose a novel approach called AIDSAFE, which leverages multi-agent deliberation to enhance safety reasoning in language models. By simulating diverse perspectives and potential objections, This method helps models develop more robust safety reasoning capabilities. Zhao and colleagues offer insights into how social biases manifest in large vision language models through imbalanced internal information utilization, providing valuable tools for detecting and potentially mitigating harmful biases in multimodal AI systems. These works highlight the multifaceted nature of AI safety research and reflect the recognition that safety cannot be treated as an afterthought but must be integrated into the fundamental design and training of AI systems. Our third research theme explores multi-agent systems and collaborative AI approaches. Studies consistently show that multi-agent systems outperform single-agent approaches on complex tasks requiring diverse expertise or perspectives. This represents a shift from the traditional focus on developing single, general-purpose AI systems toward more collaborative and specialized agent architectures that mirror human team problem-solving approaches. Li and colleagues introduce the mirror framework, which enables multiple AI agents to engage in reflection both before and after action execution. This approach improves decision-making in complex tasks by allowing agents to learn from each other's experiences and reasoning processes. Wu and team demonstrate the application of multi-agent approaches to scientific discovery with their MT-MOL system for molecular optimization. This system leverages role-specialized language model agents and comprehensive chemical tools to enable interpretable, chemically grounded feedback and stepwise reasoning. Yang and colleagues propose the Align framework for agent-environment alignment in multi-agent settings, addressing the challenge of aligning agent expectations with environment behaviors. These papers reflect a growing recognition that as AI tasks become more complex, architectures involving multiple interacting agents may become increasingly important, leveraging specialized expertise and productive disagreement to explore solution spaces more thoroughly. Our fourth research theme encompasses both advanced evaluation methodologies and multimodal AI integration. Standard benchmarks often mask specific weaknesses in model capabilities, leading researchers to develop more nuanced evaluation frameworks. Chen and colleagues introduce ME reasoning for evaluating multimodal reasoning across different reasoning types: inductive, deductive, and abductive. This benchmark addresses the need for more rigorous testing of reasoning capabilities beyond text-only contexts. Zhang and team present the MS Earth benchmark for scientific comprehension in earth science, featuring over 7,000 figures with refined captions drawn from high-quality scientific publications. Liu and colleagues developed the Jigsaw Puzzles benchmark to test spatial reasoning in vision language models, using carefully curated real-world images with high spatial complexity. These benchmarking efforts reflect the recognition that as AI capabilities expand, evaluation methods must evolve to provide meaningful assessments. Meanwhile, research has found that multimodal models that integrate text, vision, and other modalities demonstrate emergent capabilities not present in single-modality systems. These models can perform complex reasoning that leverages complementary information from different sources, suggesting that multimodal approaches may be essential for achieving more human-like AI capabilities. Across the research we've examined, several key findings emerge that provide important insights into the current state and future directions of artificial intelligence. Large language models exhibit significant limitations in their reasoning capabilities despite their impressive performance on many tasks. Studies examining mathematical problem-solving have found that even advanced models make elementary errors in calculation and logical reasoning. Safety mechanisms in current AI systems often fail to generalize properly, allowing models to produce harmful content when questions are rephrased or presented in unfamiliar contexts. This underscores the need for more robust safety frameworks that can handle novel situations and attempted circumventions. Retrieval-augmented approaches have been shown to dramatically reduce hallucination rates in specialized domains by providing models with access to relevant external knowledge. Multi-agent systems effectively leverage specialized expertise and productive disagreement, consistently outperforming single-agent approaches on complex tasks requiring diverse perspectives. Finally, despite advances in interpretability methods, the internal representations and reasoning processes of large AI models remain difficult to interpret and control, posing challenges for ensuring model safety, improving capabilities, and building trust in AI systems. The methodological approaches driving progress in AI research represent both established techniques and innovative methods developed to address emerging challenges. Code-based reasoning has emerged as a powerful approach where models generate and execute code to perform precise calculations, significantly reducing error rates in mathematical and algorithmic reasoning tasks. Multi-agent deliberation simulates diverse perspectives to enhance safety and reasoning, allowing systems to identify potential issues more effectively than single-agent approaches. Retrieval augmentation provides models with access to external knowledge repositories, dramatically improving factual accuracy and domain-specific performance, particularly in technical fields requiring specialized knowledge. Formal verification enables stepwise validation of reasoning chains for mathematical problems, ensuring the reliability of AI-generated solutions. Multimodal integration combines text, vision, and other modalities for richer understanding, enabling systems to process and generate content across different modalities. These methodological innovations collectively demonstrate how researchers are addressing fundamental challenges in AI through diverse and complementary approaches. One particularly noteworthy paper in our analysis is R1 Code Interpreter by Chen and colleagues, which addresses fundamental reasoning limitations in language models through code integration. This innovative approach combines supervised learning and reinforcement learning to train models to reason with code, leveraging the precision of programming languages to overcome natural language ambiguities. By enabling models to generate and execute code as part of their reasoning process, this method significantly reduces error rates in complex mathematical and algorithmic reasoning tasks. For example, when faced with a multi-step mathematical problem, the model can break down the computation into precise programming steps, execute those steps to obtain intermediate results, and use those results to progress toward the final solution. This represents a breakthrough hybrid approach combining neural and symbolic methods, potentially opening new avenues for enhancing AI reasoning capabilities across diverse domains. The success of this approach suggests that integrating complementary representation formats may be crucial for overcoming the inherent limitations of any single approach to reasoning. Another groundbreaking paper we've examined is AIDSAFE by Liu and colleagues, which introduces a pioneering approach to enhance safety reasoning through multi-agent deliberation. This method creates high-quality safety reasoning data by simulating diverse perspectives, allowing models to develop more robust safety mechanisms. The researchers employ multiple AI agents with different roles, such as user, assistant, and safety evaluator, to generate and refine safety-oriented dialogues. Through this process, the agents collectively identify potential safety vulnerabilities and develop appropriate responses, creating training data that captures a wider range of safety considerations than traditional approaches. Models trained with this approach show improved resistance to safety circumvention attempts, maintaining appropriate boundaries even when faced with novel or cleverly disguised unsafe requests. The AIDSAFE methodology demonstrates that multi-agent systems can identify safety vulnerabilities more effectively than single-agent approaches, representing a significant advance in making safety mechanisms more robust and generalizable. This work highlights the potential of collaborative AI systems not just for problem-solving but also for enhancing the safety and reliability of AI technologies. The mirror framework introduced by Li and colleagues represents another significant contribution to AI research, enabling AI agents to reflect both before and after action execution. This approach mimics human-like deliberation processes through agent collaboration and feedback, significantly improving decision-making in complex tasks involving tool integration. The mirror framework operates through two complementary reflection mechanisms: intrareflection, where an agent considers its own reasoning and potential actions before execution, and interreflection, where multiple agents evaluate each other's reasoning and provide feedback. This dual reflection process allows agents to refine their approaches based on both anticipated outcomes and actual results, creating a continuous improvement loop. In experimental evaluations, systems implementing the mirror framework demonstrated substantially better performance on complex reasoning tasks compared to non-reflective baselines. Agents learn from each other's experiences and reasoning processes, leading to more robust problem-solving capabilities over time. This work demonstrates how collaborative reflection can lead to more effective AI systems, particularly for tasks requiring careful deliberation and tool use. Looking toward the future of AI research, several promising directions emerge from our analysis. Developing hybrid systems that combine neural approaches with symbolic reasoning represents a particularly promising avenue, as demonstrated by the success of code-based reasoning methods. These hybrid approaches may help overcome the limitations of purely neural systems while maintaining their flexibility and learning capabilities. Creating more robust safety frameworks that generalize to novel contexts and attacks remains a critical priority, with multi-agent deliberation showing particular promise in this area. Advancing interpretability methods to better understand and control model behavior continues to be a significant challenge, as the internal representations of large AI models remain difficult to fully comprehend despite recent progress. Exploring specialized agent architectures for complex domain-specific applications offers potential for addressing challenges in areas ranging from scientific discovery to creative endeavors. Finally, establishing more comprehensive evaluation paradigms that probe specific capabilities will be essential for accurately assessing progress and identifying remaining limitations in AI systems. These future directions highlight both the substantial progress made in AI research and the significant challenges that remain to be addressed. This presentation was synthesized using GPT and Anthropic's Claude 3-7 Sonnet 20250219. With text-to-speech synthesis performed using Google's advanced TTS technology. The visual elements were generated using Grok's image generation capabilities. While the content has been thoroughly reviewed by human experts for accuracy and relevance, it's important to acknowledge that some oversights may exist. The synthesis process involved analyzing and distilling information from 39 research papers published on May 27, 2025, identifying key themes, methodological approaches, and significant findings across the AI research landscape. This approach allows us to provide a comprehensive overview of current developments in artificial intelligence while maintaining technical accuracy. All references to original research have been preserved to ensure proper attribution to the researchers whose work forms the foundation of this presentation. Thank you for joining us for this episode of AI Frontiers. We invite you to subscribe to our YouTube channel for weekly deep dives into cutting-edge AI research. By joining our community of AI enthusiasts, researchers, and practitioners, you'll stay informed about the latest developments in artificial intelligence. New episodes are released every Wednesday, exploring recent breakthroughs and emerging trends in the field. Please share your thoughts and questions in the comments section below, and help us grow by liking this video and sharing with colleagues interested in AI advances. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.